Um, Good afternoon, students. I hope I'm audible. If there is any issue, please let me know with respect to video or audio or any kind of issues in the tech team on the tech side. Please let me know. Uh, is my audio clear? Just a sec. Is my audio clear? All right. Okay, as it's not PP. Okay, Ishika Agarwal. Yes, cool. I was just waiting. Start the session by 3 because we did schedule it exactly 3 p.m. but I came on live 2 minutes early. So let's wait for one more minute for people to join in. Cool. Everything is going fine. So actually, today we'll be dealing with calculus part 2. Yesterday we had a long session on calculus part 1 where we dealt with limits, definition of limit, how to calculate the limits, and even we have seen how to do the derivative, that is f dash of x in the terms of limits. Today we will go a deep, let's say to continuity, a deep further down to way of doing the derivatives or finding the differentiation of some composite functions and etc. And we will also see how to manipulate the things with respect to inverse trigonometry and logarithmic functions when it comes to differentiation. Here we will also deal with differentiability, continuity, which is implicitly being said now. For the students who haven't seen the yesterday's lecture, it is advisable to watch it first before moving on to this because it maintains your flow in one go. So that is what I feel personally. Okay, it's already 3, so let us start with today's session on calculus part 2. So before just going on to the topic, I want you to know that we are offering 5 free mocks for IIM B UG test, which is being conducted on December 13 this year. This is the very first time IIM Bangalore is giving its admissions to undergraduate students. They are conducting their own exam on December 13th. So this exam has 3 sections like reading comprehension, quant, and reasoning. So basically, this is curated. These 5 mocks are curated by the alumni of ABC. I am alumni of ABC. A moment. One sec. Any issue? Which? Where is this? Just give me 2 minutes, guys. All right. Okay. Sorry for the disturbance. So actually, we are offering this. Fine. We are offering this 5 free mocks, which are curated by the alumni of ABC, that is IIM Ahmedabad, Bangalore, and Calcutta. So they have put in their thought and expertise in making these papers. Though they are given out to be for free for this time, they are very high quality. They are curated by taking into consideration many factors. But having said that, we are actually waiting for the sample paper, which is being released by IIM Bangalore in the first week of December, if I'm not wrong. Once we get that paper, we will have a much more clear idea on what kind of difficulty level we can expect on the exam and what kind of topics are they going to stress more on to, so that we can later curate as per the requirement the tests, the what do you say, even the live sessions which we are taking every day. So that is how we are planning. I would recommend or suggest firstly to every aspirant who is going to appear for this exam to go and try out these, to definitely go and give this to assess themselves where they are currently standing, what kind of topics they have to focus on in order to improve their score in the next few days. So, and we have also have this WhatsApp channel, which is which we post some free preparation resources, and even you can ask any of your doubts regarding the exam application or let's say preparation part or everything. So this is like a very good platform, you could say, for you people who are preparing. You'll get some peer group there to interact with, or even you can ask doubts to, even I'll be on that group, and not just me, many other people, the educators, they are at your just one step ahead. Like you can ask any doubts or anything, that would be much advisable. So having said that all, today let us start with the second part of calculus. While I am going on to this, please do understand, if you have any doubts while I discuss any topic, do not hesitate. Please feel free to post your question on the comments. I will go through it and definitely solve your doubts undoubtedly. So this is like, yesterday we discussed about limits. Yesterday we discussed what? Limits, left hand limit, right hand limit. We have discussed yesterday about a derivative. That is a these both are discussed on the calculus part 1 playlist, which you can watch if someone has missed yesterday. So basically, now we will start what is a continuity. What is the definition of continuity? A function f of x is said to be continuous at some point, let's say x equal to c, if the value of the function at x equal to c, that is f of c. What is the value of function at x equal to c for f of x? That would be f of c. This particular value equals the limit of function at x equal to c. That is, this equal to limit x tends to c f of x. This is what being set precisely in a one line definition. What is a continuous function? A continuity at c. Continuity at c is that if f of c is equal to limit x tends to c f of x. So basically, when I say limit x tends to c f of x, this implies this limit exists in the very first place. In order for that limit to be existing, we say limit x tends to c plus f of x is equal to limit x tends to c minus f of x. This is what it should happen if the limit has to exist. For the limit to exist, this should definitely take place. And let us say this particular value be some L, the limit L. Now the definition says, if this function, if f of x has to be, if we can say that f of x is continuous at point C, then this particular value L should be nothing but f of c. Should be nothing but f of c. This is what primarily the definition of continuity at particular point in a function meant to be. When I talk about this all, please do understand, which is implicitly being said here, that point C is in domain of f of x. Else f of c is not even defined, right? Because sometimes what happens, if c is not in the domain, still you would be able to find limit x tends to c plus f of x and limit x tends to c minus f of x. Even probably those both could be equal, but still try to understand, f of c should be defined in the very first place. This has to be defined. If it is not in the domain, that is, if point c is not in the domain, then f of c won't be defined. At that point, we will say it is not in the domain, so it is not defined, and we can't say that it is continuous at that particular point. So please be careful about that. I will show examples where those kind of things happen, where a graph is discontinuous, but still left hand limit, right hand limit, both are being equal. And I can also show you a point where left hand limit, right hand limit, both are unequal. So basically, we will go through those. Now, good that people are turning in out. That's good to see. So what kind of example can I take? Okay, I'll see if I had some. All right, we will do it over here. So discontinuous function graph. Let us say one function, the graph, I was able to figure it. Sorry, yeah, I will be taking a graph where let's say this is origin. So if I say that there is a function in this way, okay, that is, let's say this is y is equal to -1. Let's say this is y is equal to 2. This is y axis, this is x axis. Okay. So in this particular point, what I meant to say is that when I talk about this graph implies that for any x value which is negative, the y value is -1. How to represent this function is nothing but f of x is equal to, basically, if you see this graph point, any negative x value, the y value is being -1. So any x which is less than 0, the y value is -1. F of x equal to -1 if x is less than 0. Whereas if x is greater than or equal to 0, because you see this implies an open plot. That is, this particular line is only till here. It is not defined at x equal to 0. But here if I see, I have mentioned a closed one. That means here x equal to 0 is also part of this line. So that function would be y equal to 2 for every value which is greater than or equal to 0. Greater than or equal to 0. Yes, greater than or equal to 0. So in this particular case, if you could try to find the limits, if you could try to find the limits on both the sides, if you could try to find the limits on both the sides, here comes the case where limit x tends to 0 minus f of x, that is a value which is less than 0, slightly less than 0, that limit value would be -1, because f of x is -1 for any value which is less than 0 x. Similarly, if you check for limit x tends to 0 plus f of x, this turns out to be for any value which is greater than 0, the defined function is 2. So basically, if you see, these both are not equal. These both are not equal. If these both are not equal, first of all, then the limit does not exist at that point. Limit does not exist. So from this we could say, what we could say is that limit x tends to 0 f of x does not exist. Does not exist. So obviously this is not existing. They are not equal. They are not equal. So I would say f of x is discontinuous at 0. F of x is discontinuous at 0. Discontinuous at x equal to 0. Are there any doubts till this point, to the point which we discussed? Please feel free to ask any doubts if you have. This is fairly simple thing which I explained, but still conceptually any doubt, then definitely you should be asking me. This is one example. Now we can go with another example where let's take another function. Take another function. Let's say it looks something like this. This is an open. Something like this. Let's say this is the function where I wanted to say this will be, if you could see here, this particular f of x is not defined at x equal to 0, because there is no x equal to 0 in the domain for this particular function. That is, f of x is not defined at x equal to 0, because 0 is not in the domain. That is the reason I have given an open circle over the 2 points. But if you could observe here, this graph, if you start tending to come in the negative x direction towards 0 or from positive x direction towards 0, both are tending to a particular value. Let's say this value is some L. Say this value is some L. This particular length be some L, limit L. So now what happens is, in this particular graph, you could say that limit x tends to 0 minus f of x is equal to value L. Similarly, limit x tends to 0 plus f of x is also value L. 0 plus f of x also value L. Value L. Both are approaching towards a common value which is L. But if now we can say this limit exists. Limit x tends to 0, f of x does exist now. Both are equal also. Does exist, that is the both are equal, that is the reason they are existing, because these both are equal now. But graph is discontinuous. Graph is discontinuous because f of 0 is not defined. That is, there is no 0 in the domain. There is no 0 in the domain of f of x. But what is the condition? This particular L limit, which are both right and left hand being equal, this should be equal to actually f of 0. Then only you could say continuity. But now this is not equal, because the point is, it's not about equality or unequal, but the point is that it is not even defined. 0 is not in the domain. So if on the other side, if these both are equal, then that would be a continuous function. So this is the major difference between continuity and discontinuous function. be clear about the limits, left hand, right hand, and how to deal with this. Graph of discontinuous, this is one example we took. This is also one of the example we took. You could take even multiple examples. Like, let us see one other example where, what about, okay, there could be functions like, you got some point where you are cutting the graph, or let's say, even if you talk about tan x, if you are aware of tan x, if you take the entire real domain R, obviously it is a, what do you say this? It is a discontinuous graph. So actually there is one thing which usually happens when we talk about any graph to be continuous or discontinuous, but when you talk about tan x in the domain of minus pi by 2 to pi by 2, in that case it would be a continuous graph. If you talk about minus pi by 2 to pi by 2, in that case you could say this to be a continuous graph. So there is one, what do you say, generic definition being given in the case of continuous, that if you are able to draw the graph of function f of x without lifting your pen, I mean to say there is no struck in the graph, there is no requirement of you to lift the pen and plot it, that is you can do it at one stretch, then that is usually known as continuous. And that makes more sense because even if you see mod x, this is pretty much continuous function. Mod x is continuous because everywhere there is no any break of the point. At x equal to 0 also it is defined. So any graph where you can draw it without lifting the pen would be a continuous, else it would be a discontinuous function. Discontinuous function, something like, let's say there is one graph like this, but after, at this point it is being open, after this, let's say the graph is increasing on a straight line. This is also discontinuous. So basically anything where you are able to draw without a change of pen stroke or without lifting the pen, then you could say it's a continuous. I hope I'm clear. If any doubts, please feel free to ask. So this is about the continuity, graph of continuity. Let us see further. We have discussed this limits function graph. Let us see now what is a continuous function. So just before we discussed about continuity of function at a particular point x equal to c. That is, we discussed at x equal to c, if the function has to be continuous, then we did mention that the limit has to be existing at that extending to c. That particular limit value should be equal to f of c. But what are the conditions to say that the function is said to be continuous across entire domain? That is, a function is said to be a continuous function if it is continuous at all the points including endpoints of its domain a comma b. That is, let's say the domain is, for example, instead of a comma b, let's say the domain is 2 comma 10. If this is the domain of a function, if this is the domain, let's say this is the domain, then the condition is that any real number point you pick on in between 2 to 10, that particular point, the function has to be continuous. And at the same time, it should also be continuous at 2 and 10. That is, though there is no left side, let's say for any, I will write here, for any number between, or for any number in open 2 to 10, let's say, that is 2 and 10 are excluded. In this, for any number c, in 2 to 10, for any number c in 2 to 10, any number, you can take any, then f of c should be equal to limit extending to c f of x. If this happens, then firstly, it is continuous in open 2 to 10, but the domain is close to 2 to 10. So we should be checking the continuity. It should be continuous even at 2 and 10. It should be continuous even at 2 and 10. Even at x equal to 2 and x equal to 10. And x equal to 10. What does that mean? See, when the domain is 2 to 10, I'm pretty sure you can't take a number which is less than 2 because the function is itself defined from 2 to 10. You can't take 1.9999 because that is not in the domain. So how to check for the continuity at the end points, at the closing points, at the opening points is that this particular f of 2 is defined anyways because it is in the domain. this value should be equal to limit extending to 2 plus, because though you cannot take 1.99, you can be taking 2.001. That is, right hand limit does exist because left hand won't be existing. That doesn't make sense to talk about left hand at a starting point. So limit 2 plus f of x. This right hand limit should be equal to f of 2. And similarly, f of 10, which is defined, should be equal to limit. Now we will be discussing about left hand limit, because there doesn't exist a right hand. 10 is the last, you can't go 10.001, whereas you can take 9.999. So this left hand limit should be equal to f of 10. If this happens, that is for any number c in 2 to 10, f of c is limit extends to c f of x. At the same time, the function is continuous at x equal to 2 and x equal to 10, then f of t equal to limit extends to 2 plus f of x, and f of 10 is limit extends to 10 minus f of x. If these all conditions satisfy, then we could say the entire function f of x is continuous in its domain a to b. It's continuous in its domain 2 to 10 in this particular example. Am I clear, guys? Am I clear? Any doubts, please feel free to ask. I'll just wait a moment if someone answered out or what. So now we will see further. So greatest integer function, probably people already might have known this. What is this greatest integer function? Usually represented as step x. So, or step x. What is this greatest integer function of x is that? Why is it called step function as well? Step function because the graph is usually, if you draw the graph of this particular function f of x equal to step x, you will see that graph looks like in stepwise order. I will show you the graph. So f of x equal to step x, actually what is the definition of this is that this is equal to x if x is integer. If x is any integer, that is you take 1, 2, 3 or 0 or -1 or -2, anything. If you take step x, step of 2, that would be 2. But if it is not integer, let's say 2.3, if it is not integer, this will be equal to 2. That is the greatest integer, I would say the greatest integer which is less than x. Greatest integer which is less than x. If x is not integer, x is not integer, z is represented as integers on a mathematical way of representation. R is on real numbers, z is on integers. That's how they do it. So if this is x, if x is an integer, then it is step x equal to x, or else the greatest integer which is less than x. In this case, if you see the greatest integer which is still less than 2.3, that is 2 is less than 2.3, and this is the greatest integer which you can be taking for giving a value to the step 2.3. Similarly, if I talk about minus 2.3, what will be the answer? Now we have to consider the greatest integer which is less than 2.3, that is minus 2.3. That is, this is a greatest integer minus 3, which is definitely less than minus 2.3, and this is the greatest. The next numbers would be minus 4, minus 5. They are less than minus 2.3, but the greatest among all the set, all those is minus 3, right? So minus 2.3 step, the greatest integer function of minus 2.3 will be minus 3. Similarly, let's say minus 4.5. This would be minus 5, whereas plus 4.5 would be 4, because 4 is less than 4.5. So this is how this step function is basically defined as. In this, let us draw a graph of this y equal to step x now, as we have seen what is the condition for this function to exist. Let's say this is origin, So at x equal to 0, what happens, guys? At x equal to 0, the value should be 0 because step 0, it's an integer, so it has to be 0. Whereas any number I take from 0 to 1, that is, if I take 0.85, what is this value? This is 0. This should be 0 because 0.85, the greatest integer which is less than 0.85 is 0. So from 0, if you see, till 1, I would put open because 1 at step 1, the value step 1 is equal to 1. It is not 0 because it is an integer. So when I go any number between 0 and 1, it will be 0, but exactly at x equal to 1, that should be 1. So I'll draw here, I'll start the next thing from, if this is x equal to 1, x equal to 2, 3, 4, 5, let's say. So from here till 2, any number between 1 and 2, it should be what? 1.8 or anything you take, step value has to be 1. Similarly, so here it starts again. For 2 to 3, this will be open. For 3 to 4, this will be open. Similarly, if you could check for minus 1, minus 2, minus 1, minus 2, let's say even minus 3, any number. From 0, if you see 0 is here, but if you check here minus 1, this would be open because at 0, we have already seen the value as 0. So, but at minus 1, it would be what? Like this. It should be in this way. Because at x equal to minus 1, it is minus 1. Anything like minus 0.5, minus 0.6, it is all still minus 1. Whereas, you see next minus 2. At x equal to minus 2, this has to be minus 2. But from minus 1 to minus 2, if you see, other than minus 1, rest of all are minus 2. So this is basically a step function because if you see the way the graph is coming, the line, then endpoint, then again starting, then again this endpoint is going to be a new starting point for the next integer. So this is the way the graph looks like. It looks like a step. That is the reason this greatest integer function is also known as step function. At the same time, you could observe here, the graph is discontinuous at every integer. That is, see from minus 2 to minus 1, if you see, it is coming on a straight line, but it is getting discontinued at x equal to minus 1. Similarly, again from minus 1 to 0, if you see, minus 1 to less than 0, it is being on a continuity path, but whereas at x equal to 0, it is breaking again. So for every integer, this graph is breaking. I could say this implies greatest integer function GIF is discontinuous at integers. At integers. Whereas this has to be a continuous function for any number which is not an integer on the real number scale. It has to be continuous for any number which is not an integral scale. Okay, any doubts, guys, till now? We have discussed what is the left hand, right hand limits and how the continuity is defined as such, some graphical representation. We have shown a case where left hand limit, right hand limit being equal, but still that value is not equal to f of c, or f of c probably is not defined at that particular point still. And we have also seen, what did we see? We have also seen the greatest integer function and another discontinuous function graph. So one more case which I wanted to cover is that when I talk about continuity on the limits way, we have seen this graph, right? We have seen this graph and we told that left hand limit and right hand limit being equal, here LHL being equal to right hand limit, and I told that value to be L at x equal to 0. I'm talking about at x equal to 0. We have seen this is happening, but f of 0 is not being equal to L. That is, this value is L, limit L. So, but we have said that that value is not there. Let's say at x equal to 0, this graph also contains a point which is 0, minus 3. That is, f of x is this graph for all the x except at 0. That is, f of 0 is defined. 0 is in the domain and y value is minus 3. This is the case which I was discussing about, where right hand limit, left hand limit both are being equal to L, because I'm coming from 0 minus or 0 plus. 0 minus if I'm approaching, still I'll be ending at this point. 0 plus also I'll be ending at this point. both are equal to L, the limit exists, but that L is not equal to minus 3. But that L is not equal to minus 3, which is f of 0. That implies this is a discontinuous function still. So please ensure that both the left and right hand limits are equal, finite, and that particular value is equal to f of c. No doubt, sir. Okay, good. So this is what a continuity and discontinuous function. This is one greatest integer we have discussed. Let us see further. We will take some examples after this. Algebra of continuous functions. In yesterday's session, we have taken this algebra thing on limits and derivatives. On derivatives, we did do UV rule and U by V rule, product rule, that is it is also called the term which is given to this product rule basically. If to the people who have seen yesterday's session, product rule is also usually called as Leibniz rule. See, definitely you need not remember any of this rule name as such for the in the perspective of exam, but still sometimes you might read a solution where it says let's apply Leibniz rule, and then you start pondering about what is this, we have not taught, didn't know about this. That's basically a product rule, which is UV rule, which we discussed yesterday, UV differentiation. So similarly, when we discussed yesterday, we discussed subtraction, addition, multiplication, division in the terms of limits, in the terms of derivatives, both of them we discussed for the limits as well. So similarly, now let us discuss about continuous functions. That is, if f of x and g of x, there are two functions. If f of x and g of x are continuous at x equal to a, let's say, are continuous at x equal to a, then I could say one thing is f of x plus or minus g of x is also continuous at x equal to c, is also continuous at x equal to a, sorry, continuous at x equal to a, I mean to say at x equal to a. This is one thing. Second, we can also similarly talk about product f of x into g of x is also continuous at x equal to a. And the third thing is division rule, which says f of x by g of x is also continuous at x equal to a, is also continuous at x equal to a. But in the case of division, please do understand that provided only g of a is not equal to 0, because you can't say f of x by g of x and talking about its continuity at x equal to a, because if g of a is 0, this particular function f of x by g of x does not exist at that x equal to 0, because at that case it would be a undefined, because the domain will not consist 0. So this is what algebra of properties is. Because how to prove this basically, see, yesterday we have discussed about limits proof, right? The way addition, subtraction limits will be same as the individual summation. Here also the same thing works, right? If I say some new function h of x is equal to, let's deal about the product now, f of x into g of x. You know, if it is said that this both are continuous at x equal to a, in order to see if h of x is continuous or not, what we will be doing, we'll be just doing limit x tends to a h of x, which is nothing but limit extending to a f of x into g of x, f of x into g of x. But the product rule of limit says we can do this as a individual limits, f of x into limit x tends to a g of x. So now we are said that these both f of x and g of x are continuous at x equal to a. If these are continuous at x equal to a, limit x tends to f of x should be f of a, whereas limit x tends to a g of x should be equal to g of a. So I'm getting limit x tends to a h of x equal to f of a into g of a. But what is f of a into g of a? Which is nothing but h of a, because h of x is the product just. So this is h of a. So we have proved that limit x tends to a h of x is equal to h of a. Once we prove this, then it's done. We can say this is a continuous function. h of x is continuous at x equal to a, continuous at x equal to a. So similarly, you can prove for addition, division as well, because division also the same thing we do. Entire limit extends to f of x by g of x, then we separate it as limit extends to f of x by limit extends to a g of x. Each one is f of a and the denominator becomes g of a. So f of a by g of a would be h of a in that particular case as well, but only requirement is g of a is not equal to 0 in the case of division. So this is about algebra of continuous functions. Now I would be giving 2 minutes. Today there will be no timer on the screen, but I'll be giving 2 minutes for each question. Please solve this. After this, I will be explaining this question. If anyone has solved and they are confident about their answer, they can post the answer on the comments, the option. There is no big, I mean, it's a pretty just application of the definitions which we discussed previously on today's session, or even the yesterday's session, let's say, because everything is connected, interconnected in calculus. You can't just remove it or separate them, by the way. All right. So I guess the 2 minutes timer is up, and let me solve this question for you guys. Which is true among given options if function f is defined by ax plus 1 if x is less than or equal to 3 and bx plus 3 if x is greater than 3, this function is continuous at x equal to 3. If function is continuous at x equal to 3, then what is the relation between a and b is what being asked. So what is the definition for continuous function? To be for the function to be continuous at x equal to c, for the function to be continuous at x equal to c or x equal to a, let's say, f of a is equal to limit extending to a f of x. Limit extending to a f of x. Now it is being said that it is continuous at, that is nothing but what is this limit extends to a f of x, which is also equal to limit extending to a plus f of x, right hand limit, and at the same time that is also equal to left hand limit. This is also equal to left hand limit. So if this is the case, how to deal with this? See, what is f of 3 now? What is f of 3? F of 3 is that at x equal to 3, we should be taking ax plus 1. So a into 3 plus 1. F of 3 is a into 3 plus 1. If this is given, what is the limit extends to 3 plus f of x and limit extends to 3 minus f of x? Limit extends to 3 plus f of x is nothing but any number which is greater than 3, we should take bx plus 3. So b into 3 plus 3, bx plus 3. Here x we will substitute 3 because we are dealing about limit extends to 3 plus. So this is right hand. What about the left hand limit? That is extends to 3 minus. Extends to 3 minus f of x. Any number which is less than it, we will be taking ax plus, what is given, ax plus 1, x less than 3. So if that is the case, the limit will go a into 3 plus 1. So these both have to be firstly equal and that particular value should be equal to f of 3. we are sure these both are anyways equal. That is f of 3 and left hand limit are equal. But now we have to just ensure right hand and left hand limits are same. That is 3b plus 3 is equal to 3a plus 1. This implies 3 into a minus b is equal to 2. So a minus b is equal to 2 by 3. A minus b is equal to 2 by 3. This is the condition which we are getting for, that is option D, for this particular function to be continuous at x equal to 3. Continuous at x equal to 3. So this is fairly simple question. I suppose you people to be doing it very faster than the time which I had given. So let us see further. What is differentiability? Yes, today's session there will be a bit less questions compared to yesterday. Yesterday we did take lots of questions indeed. I guess more than 13, 14 or even higher. So today it will be a bit less number of questions because yesterday we went over the time a lot. That is, the session should be ended by 4:30, but it did continue till 5:30. So I did today I did not want that to happen. Today I'll be focusing on topics, concepts, and for exemplar problems, additional 1 or 2 questions on each important topic. Further, after dealing with the calculus concepts, we can take one problem session if time permits before your exam. Indeed. Anyways, you have to keep practicing from your side all the topics for the exam. Now let us see what is differentiability. Differentiability is, see, yesterday we did see the derivative part. We did see f dash of x is nothing but limit h tending to 0 f of x plus h minus f of x by h. This is what we have seen yesterday for a function derivative, that is f dash of x, or we can also call this as what? Dy by dx. Dy by dx if y is equal to f of x, I mean to say, or d by dx of f of x. So this particular derivative is defined as limit h tending to 0 f of x plus h minus f of x by h. In this particular thing, a function is differentiable at point C if both right hand derivative and left hand derivative at x equal to c are finite and equal. See, when I mentioned about limit h tending to 0, this is equal to limit h tending to 0, this particular value is f dash of x. We did imply obviously that firstly this limit exists, right? This limit has to exist in order to define in this way. In order to be defined in this way, that limit has to be existed. For the limit to exist, we do know that right hand limit should be equal to left hand limit. That is h plus f of x plus h minus f of x by h. This particular thing should be equal to limit h tend to 0 minus as well, right? 0 minus as well. Then only we could say this particular limit exists. That is what being told again. But yesterday we did apply this particular thing, but we did not. I did mention that this particularly exists. So why did we say this? Basically, why are we saying that this is a differential at c? Right hand derivative and left hand derivative at x equal to c are finite and equal. Because there can be a question framed in a way that you apply directly limit h tends to 0 and you give some value for f dash of x. It is pretty much possible that in the very first place, probably right hand derivative and left hand derivative are not even equal. So that limit does not exist. In that case, you would say f of x is not differentiable. F of x is not differentiable else. F of x is not differentiable at that particular point. Not differentiable at x equal to a if left hand derivative is not equal to right hand derivative. So we will take an example for you to understand better what am I exactly referring to. See this. Now we will take one here. There are two statements in this particular thing. One, we will discuss the one which I was mentioning about, where the function is not differentiable at some particular point. and every differentiable function is also a continuous function, but converse need not be true. That is, every continuous function may not be a differentiable function, but every differentiable function is definitely a continuous function. How to prove this? Let us see why are we saying in this way in the very first place. If a function is differentiable, it is saying that every differentiable function is also a continuous function. So we could write this f dash of x is equal to nothing but limit, what is this? Limit x tending to c, f of x minus f of c by x minus c. Both are same ultimately. Why is it same? Why is this particular thing coming out to be same is that what we did mention is limit h tending to 0 f of x plus h, one sec, f of x plus h minus f of x by x plus h minus x. That is what it is, because f of x plus h minus f of x by h is nothing but x plus h minus x. Basically, what is this entirely? This is nothing but slope, that is point P and Q. Yesterday we did discuss one point is x comma f of x, the other point is x plus h comma f of x plus h. So taking change in value of y to the change in value of x in an infinitesimally small interval. That is, there is no big gap. That is, this h is almost tending to 0 but not equal to 0. That is, there is a small difference between x and x plus h, which is infinitesimally small. So if you see this f dash of c and saying that x is tending to c, x is tending to c, then this is f dash of x. Why? Because you could also write this particular x minus c. You could write this particular x minus c as some k. Let's say this is some k. Let x minus c is h, not k. Let us see x minus c as h. Let x minus c is h. Then how can I rewrite this particular thing? Let us see. F dash of x is equal to limit x is tending to c, na? Then if x is tending to c, this implies x minus c is tending to 0. That is nothing but h is tending to 0. So I will write limit h tending to 0. What is x? X can be written as f of c plus h. X can be written as f of c plus h minus what is f of c? C can be written as x minus h, isn't it? Because we did mention it is x minus c by f of x minus f of c by x minus c. If x minus c is h, so denominator will come h. But whereas here f of x minus f of c, what is f of x? X is nothing but h plus c. F of x is h plus c. Or we can also write c as x minus h. That is, f of c is x minus h. C is x minus h. Now tell me guys, what happens in this particular case when I am talking about c? See, let us put it in only one term. That is either h and x, or but we should not take c. That is nothing but we are getting limit h tending to 0 f of x minus f of x minus h. What is h plus c is x, right? Instead of writing x plus c, let us just write, instead of writing h plus c, let us just write x. So this is what we are getting. But what is the thing which we have seen? We have seen limit h tending to 0 f of x plus h minus f of x by h. This is what we have seen yesterday. Now tell me, what are we doing at this particular thing? What are we doing at this particular thing? Aren't these both equal? How to say these both are equal? See, now in this particular case, we are seeing the change between x comma f of x, and point q would be x minus h comma f of x minus h. That is still h, the value of h, I mean to say, is between 0 to 1, but it is infinitesimally small value. Still it is infinitesimally small value. Here we are seeing change in the value of y, that is f of x minus f of x minus h, when it is moving from x to x minus h, x minus x minus h. So this is the same, I mean to say, you check for these both points, or you can also check for p x comma f of x, or q being x plus h comma f of x plus h. Aren't these both equivalent? because either instead of going forward by a infinitesimally small, you're going backward. That is, instead of checking for right hand, now we are checking for left hand. I mean to say this thing you could count it to be as left hand. This one you could term it to be right hand. In the very first place, when I say that this differentiation is this particular value, I am inferring that that value is nothing but equal to left hand and right hand. Both should be same. So this value and this value should be same. So why did I explain this all? Why did I explain this all is that instead of writing limit h tends to 0 f of x plus h minus f of x by h, instead of writing this, you can also write, instead of writing this, you can also write f dash of x is nothing but limit x tends to c f of x minus f of c by x minus c. Both are pretty much same. When I write in this way, what are we inferring? So I could say f of x minus f of c is equal to f of x minus f of c by x minus c into x minus c. I can write this. There should not be any issue over here. Instead of writing f of x minus f of c, I would be just dividing and subtracting with x minus c. When I do this and apply limits, I will understand now that limit x tending to c f of x minus f of c, this particular value is nothing but, because this is differentiable, this is limit x tending to c f of x minus f of c by x minus c into limit product rule is what I am taking now, limit x tending to c x minus c. I just wrote f of x minus f of c as f of x minus f of c by x minus c into x minus c, and I did apply limit on both sides. This implies me that what is limit x tends to c f of x? Limit x tends to c f of x minus algebraic property, subtraction, just taking both limits, limit x tending to c f of c. This is equal to, what is this value? This is f dash of c. This is f dash of c, because it is being said in the statement given that differentiable function is also continuous. Differentiable, we are already being said that that function is differentiable. So this value should be f dash of c. This value should be f dash of c into, when x is tending to c, limit x minus c will be 0. This value should be 0 because x is tending to c, then x minus c limit should be 0. But f dash of c is a finite value because it is differentiable. Now this implies limit x tending to c f of x is equal to, see, this is 0, right? F dash of c into 0, this is a finite number, into 0 is 0, equal to limit x tending to c f of c. But what is limit extending to c f of c? This is the f of c value is what we are discussing about. There is no x. F of c is the constant. We can get that out. F of c is the constant. There is no x. We'll get that out. So this value is f of c only. This value is f of c. So I proved limit x tends to c f of x is equal to f of c. Then obviously, if this is being true, it is continuous at c. Continuous at c. Continuous at x equal to c. So in order me to prove this particular thing, that every differentiable function is also continuous function, I did take what? I did just simply take this f of x minus f of c is equal, can be written in this way, divide and multiply, then apply limit on both sides. It is being said that the function is differentiable. So this is f dash of c, a finite value, into 0. So limit x tends to c f of x is equal to f of c. If I prove this, then it is directly continuous at x equal to c. Now we did prove that it is continuous at x equal to c. What about the other thing? That is, but the converse need not be true. We will see why this converse need not be true now. With the example being f of x equal to mod x at x equal to 0. F of x being mod x at x equal to 0. Let us do that. F of x being mod x at x equal to 0. See, what is f of x is equal to mod x is nothing but, this is nothing but modulus function x if x is greater than or equal to 0 minus x if x is less than 0. minus x if x is less than 0. If this is the thing, how does mod x graph look like? Mod x look like y is equal to minus x if x is less than 0 and y is equal to x if x is positive. This is how mod x graph looks like, y equal to mod x. Now let us focus on this point 0 comma 0. Is it continuous? It is definitely continuous because the graph can be drawn without lifting the pen, that is y equal to minus x and y equal to x. When I am being able to draw in that way, now we should be saying that this particular graph is continuous for sure. Continuous at x equal to 0. Continuous at x equal to 0. But I will prove that it is not differentiable at x equal to 0. But this graph is not differentiable at x equal to 0. Let us see why is it not differentiable at x equal to 0. Because now let us try to find right hand derivative. Right hand derivative. This has to be equal to limit h tends to 0 plus f of x plus h minus f of x by h. Right? Now, f of x plus h minus f of x. H being a positive number which is greater than 0. Tell me if this is f dash of x. This is what? F dash of x. This is f dash of x. This is f dash of x. So let us do right hand at 0. Our interest is at x equal to 0. So let us try to find right hand derivative at x equal to 0 and at x equal to left hand derivative at x equal to 0. Both the derivatives at x equal to 0, I mean to say. I will write here. So if I talk about right hand derivative now, at x equal to 0, the rate x equal to 0, this will be equal to f of 0 plus h minus f of 0 by h. Limit. I mean to say entire thing is limit. Let me get some space somehow. How to get my space? I will do it over here. I would say right hand derivative is equal to limit h tending to 0 plus f of 0 plus h minus f of 0 by h. So, what is f of 0 plus h? F of h. What is f of 0 plus h? It is f of h. Yeah. What is f of 0 plus h? It is f of h. So, here h is positive. 0 plus h is positive. So, if h is a positive, f of h should be what? As per the definition, if h is positive, f of h should be h modulus function. So, limit h tending to 0 plus, here you will get h, f of 0 is 0 by h. H by h is coming out to be 1. Right hand derivative is coming out to be 1. Similarly, let's check what about the left hand derivative. Here we did talk about right hand. Here I will be now doing the left hand derivative. What is the left hand derivative? Here it would be limit h tending to 0 minus, because left hand, f of 0 plus h minus f of 0 by h. This won't change because see, I mean to say the way of writing f of x plus h minus f of x by h. This is nothing but again f of h, f of 0 is 0 by h. But what is f of h for h being less than 0? Now h is 0 minus, that is h being less than 0. So mod x is minus x. Now I would write this as minus h by h. So the left hand derivative is minus 1. The left hand derivative is minus 1, whereas the right hand derivative is 1. Both are not equal. Right hand derivative coming out to be h by h, which is 1. Left hand derivative is coming out to be minus 1. So right hand derivative and left hand derivative are not equal. So at x equal to 0, this is not differentiable. Not differentiable. Not differentiable function at x equal to 0. Whereas it is continuous. It is continuous at x equal to 0 mod x, but it is not differentiable at x equal to 0 because left hand derivative is not being equal to right hand derivative. We did prove one right hand derivative being positive h by h1, left hand derivative is coming out to be minus h by h, which is minus 1. So the logic is that if the function is differentiable, it is definitely continuous, but if function is continuous, it need not be that function is definitely differentiable. That is, every differentiable is continuous, but every continuous need not be a differentiable. This is a example to prove that particular statement. I hope I am clear, guys. We'll move forward. I hope I am clear. So let us see now composite functions or chain rule. Composite functions or chain rule. What is a composite function or chain rule in the case of differentiation is that one thing, if there is a function f of x is equal to some y, we say f dash of x is equal to dy by dx. Y is equal to f of x, so f dash of x, that is derivative of f of x, is dy by dx. This can also be written as what? dy by dt into dt by dx. Any issues in writing in this way? Because ultimately, if you see, dt will go away and you will again get dy by dx. But why did I write dy by dt into dt by dx? That is, why did I write it in a chain format? Instead of directly writing dy by dx, why did I multiply and divide with a dt? Why is this t being taken is that sometimes you won't be finding a simpler equation directly to differentiate. That is, every time you want to be finding something like y is equal to x or y equal to x power n, like we discussed yesterday. For x power n, we know it is n into x power n minus 1 vagera. But whereas when it comes to a functions, like let's say, one sec. Let's take an example. How do we do the y is equal to sine of x square? How to do the differentiation of this particular function sine of x square? Here we say this particular y dash is nothing but dy by dx, right? Now let the way to solve this is let x square is equal to t. In that case, what will happen? Y is nothing but sine of t. I'm taking x square as t, then y would become sine of t. Instead of doing differentiation of y with x, now I will write this as differentiating y with the t into differentiating t with x. Both are same because dt goes away and I get dy by dx. When I say this, what is the value of dy by dt if y is sine t? Y is sine t, I do know dy by dt is nothing but cos t. I do know dy by dt is cos t because sin theta differentiation is cos theta. So dy by dt would be cos t. So this would be cos t into, what about dt by dx? I know I took x square as t na. I took t as x square na. So what would be dt by dx? This differentiation would be 2x power 1 because we do know that, instead of writing this, we do know that when it is x power n, the differentiation is n into x power n minus 1. So 2 into x power 2 minus 1, which is 2 into x power 1, which is 2x. So dt by dx is nothing but 2x. Now this can be written as 2x cos t, but instead of writing t, I would directly write as x square. So ultimately we got dy by dx is equal to 2x into cos of x square. 2x into cos of x square. This means, what did we ultimately do? We were given the equation or the function as y is equal to sine of x square. So while we were given this y is equal to sine of x square, implicitly what we did is dy by dx, that is differentiation, is simply we did this cos of x square, but into the function which is inside the theta is also differentiated. So we get into 2x. This is the chain rule. This is the product chain rule. Basically, we did take x square as t and we end up getting this. So the reason why did I what do you say? Why did I take it as t and explain to you is that you should understand the derivation. I mean to say this particular point. We can write it in this way and then prove it. But from when you solve the questions on your own, please try to do it directly after doing for 2 to 3 times by taking tea. First, you practice by taking tea. First, take tea, but after a while, that is after, let's say you have solved some 20, 30 questions, or let's say you are good at it, then do not always take tea, because that will just waste your time during the exam. It is simple that when you get y equal to sine of x square, you do dy, the differentiation is nothing but, if usually it is theta, instead of sin x square, if it is sin x, we simply say the differentiation is cos x. But now we say cos x square into, I will differentiate this, the part which is inside the sine angle, that is x square differentiation will be multiplied. So basically, why did we do that? We did that because we are able to write it in this way in the very first place. So this is what precisely the chain rule is. Any doubts, please feel free to ask me. This is a chain rule thing. Now let us see a question on this. Solve this, guys. I'll give 1 minute to this question. Solve this. I'll be explaining it after 1 minute. It is also a pretty simple question indeed. The same part as we have done just now, the one we discussed, the chain rule, the same thing has to be applied over here. You would have understood the concept, then definitely it's easy to apply. Okay, now I will solve this for you guys. So please do check on your notebooks if you have got the right answer or not. We were given y is equal to cos of sin x. The way of doing this is what I said. Let assume this sin x to be some value t. Let sin x to be t. Then I can write y is nothing but cos t. I know dy by dx is what I have to find. This is nothing but dy by dt into dt by dx. Into dt by dx. So what is dy by dt if y is cos t? This would be minus sin t. Because cos theta's differentiation is minus sin theta, as we have proved yesterday, into dt by dx. I took sin x as t, so this implies what? dt by dx is nothing but cos x. Cos x, because t is sin x, dt by dx is cos x. So this one I can write as cos x. This one I can write as cos x. Now, what is this minus sine of, what is this t? T is nothing but what? Sin x, right? So instead of writing in the terms of t, I would write sine of sin x into this cos x. So basically minus sin t cos x, which is nothing but minus sine of sin x into cos x. So this is the differentiation for the given question. Cos of sin x is minus sine of sin x into cos x. This is the application of chain rule. See, instead of I did show you by taking t, but if it is in the exam timer is given and everything, I will simply do what? I will simply say f dash of x is nothing but cos theta differentiation is minus, see, f dash of x is nothing but cos theta differentiation, which is minus sine of theta. Theta is here sin x, but again I should differentiate the theta, so sin x differentiation should be cos x. That is simply, you could say f dash of x is minus sine of sin x into cos x. That is how we have to do in the usual examination point of view, which can save your time. Now this is one more question. Now I will be giving you, let's say 2 minutes. Do this and verify with the answer which I would get once I solve this. 2 minutes. All right, guys. Let me explain this question. Derivative of sine of ax plus b by cos of cx plus d. See, how to do this is the same u by v rule which we discussed. U by v whole differentiation is nothing but v into u differentiation minus u into v differentiation divided by v square. Divided by v square. When I do this, in this particular case, f dash of x should be equal to what? V is cos of cx plus d. So I would write this cos of cx plus d into u dash. What is u? U is sine of ax plus b. Sine of ax plus b. So sine of ax plus b differentiation would be cos of ax plus v. But again, as we discussed on the product rule or the chain rule, that sine of ax plus b differentiation would be cos of ax plus b into the differentiation of the inside given part, the differentiation of ax plus b, which is nothing but a. The differentiation of ax plus b is nothing but a, because what is the value of d by dx of ax plus b? It is simply nothing but a into 1 plus 0, because differentiation of constant is 0 and differentiation of ax is a. So it is into a minus, now u. What is u? U is sine of ax plus b. So I will write this as sine of ax plus b into, now we are doing into v dash, into this particular v dash. So when I am doing this particular v dash, cos of cx plus d, na, v is cos of cx plus d in our thing, v is cos of cx plus d. So what is v dash? V dash would be minus sine, because cos theta differentiation is minus sine theta, minus sine into cx plus d. But again, into, we should be differentiating the thing which is inside the theta, that is differentiation of cx plus d, which is c, into c. This whole thing divided by, we get v square, that is cos square of cx plus d. This is how we have to solve the u by v. You can rewrite this as a into cos of ax plus b into cos of cx plus d minus into minus plus. So plus c times of sine of ax plus b into sine of cx plus d. Sine of cx plus d. Minus into minus plus. Here we have a as a multiplying constant. Here we got c as a multiplying constant. But we got cos of ax plus b into cos of cx plus d, sine of ax plus b into sine of cx plus d. This entire thing divided by cos square of cx plus d. This is what the differentiation of this particular given term would be, because we are just doing u by v, but in this particular case we are applying the chain rule, where we are applying two things. One is u by v rule, the other is we are applying the chain rule. When I am differentiating sine of ax plus b, I am writing it as cos of ax plus b into a. That is cos of ax plus b into the part differentiated which is inside the cos. Similarly, here when I differentiate cos of cx plus d, I wrote minus sine of cx plus d into c. That is the part which is differentiated for the inside thing. So we get ultimately this thing. When I write u and v, we need not write anything. Only just u and v is what we will be writing. We won't differentiate it, right? So don't do a mistake of differentiating even this thing and writing into c. So you get ac. That is not what it is. Only while differentiating, you will do the inside part as well. So this is what you will end up getting. Hope this is clear. If any doubts, please feel free to ask. So this will be the equation which you will be getting when you differentiate this particular function. Okay. Now we discuss this. We will discuss one more concept: derivatives of implicit functions. So sometimes y, if you see in this particular case, it is not given directly in the terms of x. Y is not given directly in the terms of x. If y is equal to cos x, or y is equal to x square, or y is equal to 5x square plus 3, these all are what? These all are explicit functions. These all are explicit. That is, y is clearly being given in the terms of only x. Y is given in the terms of only x. Whereas here, if you see, you can't write y only in the terms of x. That is, y is given as nothing but basically cos x minus sin y. So you are unable to write y in the single term of x. I mean to say, you cannot bring all the y's to one side and say this is what y is equal to in the terms of x. This is known as implicit function. So if this is given and the question is to find dy by dx, that is the differentiation of y with respect to x, how to do? How to approach? See, in this particular case, what we usually do is, given y plus sin y is cos x, the given function or this thing, both are same. I'm just writing the given function. You just take the given thing as it is and you differentiate on the both sides. What does it mean to differentiate on the both sides? I mean to say, when I'm talking about differentiation entirely, I mean to say, when I talk about differentiating this entire thing with respect to x, I would say this part would be dy by dx, because differentiating y with respect to x, the first term is y, right? The first term is y. So when I differentiate that particular term with respect to x, I get dy by dx plus second term is sin y. Second term is sin y. I am differentiating this sin y with respect to x. Then I should be getting cos y into again what? Dy by dx. Because see, what does it mean to differentiate y with respect to x? That is dy by dx. That is what I have written. What is it to differentiate sin y with respect to x? Sin y with respect to x is nothing but, we will write this as cos y into dy by dx. Why? Why am I writing this in this way? Because sin theta differentiation is cos theta, but I have to differentiate the value which is inside the theta, that is y, with respect to x into dy by dx we get is equal to, now differentiate cos x with respect to x. Basically, we are differentiating the entire equation with respect to x, given equation with respect to x. So when I differentiate cos x with respect to x, I'll get minus sin x. Again, I'll differentiate what? Inside part, dx by dx. This is 1. This is anyways 1. That is nothing but, here when it is sin y, we take cos y into dy by dx. When it is cos x, we take minus sin x into dx by dx, because inside part is x now. So instead of y, it will be x on the numerator. That is nothing but basically differentiation of cos x with respect to x is minus sin x. This is nothing but just simply saying it is minus sin x. When I do it in this way, what I end up getting is that, fine, it's fine, I'll write here. So dy by dx now can be taken common on the left hand. I will be getting dy by dx into 1 plus cos y is equal to what? Minus sin x. So this is what we are getting. So what is dy by dx can be written, therefore this particular dy by dx is nothing but minus sin x divided by 1 plus cos y. This is how we have to deal with the implicit functions. Implicit functions. We did just take the equation as it is given. We differentiate it on the both sides with respect to x. Then we get dy by dx plus cos y into dy by dx minus equal to minus sin x. So dy by dx taking common, we get it is equal to minus sin x by 1 plus cos y. Is this clear? So this is how we have to deal with respect to the implicit functions, which is given in this way. Y plus sin y is equal to cos x. Implicit functions differentiation. Let us take this example now, the point which we discussed. I'll give you 2 minutes. Apply that particular thing and try to get the answer for this dy by dx. After 2 minutes, I'll explain how to do this. Try to do this now. All right. Let me deal with this question. We should find dy by dx if x plus sine of xy minus y is equal to 0. It is an example of an implicit function which we have seen previously just before this, in which you cannot write y in sole terms of x. Instead, the equation is given in combination of x and y. Now, how to deal with this is we will differentiate the entire both left hand and right hand with respect to x each term. When I differentiate x with respect to x, I would get nothing but 1, that is dx by dx, because we are differentiating x with respect to x. When I differentiate sine of xy with respect to x, I will be getting d of sine of xy, d of sine of xy with respect to x minus dy by dx is equal to 0. See, what did we do? We just differentiated the left hand side and right hand side with respect to dx. So we get x differentiation is dx by dx. Sine of xy differentiation is d by dx of sine of xy, which we have to perform the differentiation for this particular term. Y's differentiation is dy by dx. Now dx by dx is 1 plus, what about d by dx of sine of xy? D by dx of sine of xy. Now d by dx or sine theta differentiation is cos theta. So d by dx of sine of xy is nothing but firstly cos of xy into what will I be doing? I should be doing differentiating this inside part xy with respect to x. That is what we have seen during the chain rule application. We did see that Sin theta differentiation is cos theta, but if it is something like sin x square or anything, we will write cos of x square into differentiating xy with respect to x. When I differentiate this with respect to x, what do I get? How do you differentiate xy whole dash? This is what we have to do. Xy whole dash, apply UV rule, na? UV rule. What am I getting? X into y dash plus y into x dash. So this is the thing, y into x dash. I would be getting nothing but here when I differentiate this, x into dy by dx plus y into dx by dx. Dx by dx is basically 1. So basically xy differentiation is x into dy by dx plus y into 1. Y into 1 because x differentiation is 1 minus dy by dx is equal to 0. So ultimately what we are getting? We are getting this part as, if I take 1 over here dy by dx to that side, we get 1 is equal to, or 1 plus dy by dx into, here I am getting x cos of xy plus y cos of xy is equal to dy by dx Now I can take this particular term onto the right hand so that I could directly write dy by dx now. What is dy by dx now? Dy by dx is nothing but 1 plus y into cos of xy divided by dy by dx going that side, then I'll get dy by dx into 1 minus x times of cos of xy. 1 minus x times of cos of xy. So dy by dx is nothing but 1 plus cos of xy by 1 minus x cos of xy. So the given equation is as it is differentiated with respect to x on both the sides. We get 1 plus cos xy into x dy plus y dx minus dy by dx is equal to 0. That is nothing but dy by, just rearranging the term from left hand to right hand and writing it in this way, dy by dx is 1 plus y of 1 plus y into cos of xy divided by 1 minus x into cos of xy. This is how we have to deal with the implicit equations. Any doubts, guys? Let me check the comment section. All right, fine. So this is 1 plus y of cos of xy by 1 minus x of cos of y. Fine. Solve this now. The similar application. 2 minutes again. Please solve this. I'll explain this in 2 minutes. I will wait for another, let's say 30 seconds. You can solve it by then, and then you can verify your solution with the one which I am going to get when I solve this right now. All right. I will solve this now. So now the same story again, given a implicit equation xy plus y square is equal to tan x plus y. What we should be doing now? We should be differentiating on both the sides with respect to x, right? So let us do it differentiating both sides. I'm writing here both sides differentiate with respect to x. WRT is nothing but with respect to x. What will come then? XY differentiation with respect to x. First term is xy. Differentiation with respect to x gives me 1 into y plus x into dy by dx. Because first UV rule, I am applying UV rule. XY is a UV. So x differentiation is 1 into y plus x into, now y differentiation is dy by dx. Plus what is the differentiation of y square? Y square is nothing but 2y into dy by dx. Because usually x power n differentiation is nothing but n into x power n minus 1. So y square is 2 into y, but into dy by dx, because I am differentiating with respect to x. This particular side should be equal to what? Now this thing should be equal to, let us differentiate on the right, the terms which are on the right hand side, which is tan x and y. Differentiating tan x with respect to x is nothing but secant square x. Differentiating tan x with respect to x is nothing but secant square x. We did prove yesterday differentiation of sin x is cos x is minus sin x, tan x is secant square x. We did prove all the three yesterday. So we are applying just the same thing. First we applied uv and then y square is 2y into dy by dx. That should be equal to tan x differentiation with respect to x is secant square x, plus differentiating the term y with respect to x, the last term, which is dy by dx. So we will just do this. So we are getting nothing but y plus dy by dx can be taken on this side. I get x plus 2y into dy by dx. So x into s. 2y dy by dx just taking common over here. I get x plus 2y is equal to secant square x plus dy by dx. Again, dy by dx, let us bring it to the left hand. Then what am I getting? I'll be getting dy by dx into x plus 2y minus 1 is equal to, what is this? Secant square x. I'll take this y onto the other side. So secant square x minus y. Secant square x minus y is nothing but dy by dx into x plus 2y minus 1. Therefore, simply I can write dy by dx is nothing but secant square x minus y divided by x plus 2y minus 1. This is what dy by dx is. We got dy by dx is secant square x minus y by x plus 2y minus 1. You can verify if you have reached to the same solution or not. If not, then do identify where are you going wrong, where did you make a mistake, because this is the absolute solution where you end up doing the differentiating on both sides with respect to x and get your desired answer. Any doubts? Hello, sir. Okay, hello. Tell me if you have any doubts. I guess you have joined recently, just now. Okay, fine. No worries. Hello, Math Magic. Is this Math Magic? Crazy, man. Your profile photo has a calculator in it. Okay. So, xy plus y square is equal to tan x plus y plus x into dy by dx plus 2y into dy by dx is equal to secant square x plus dy by dx. So you would be getting secant square x minus y by x plus 2y minus 1. Let us go further. Now, this is the slide now which I thought of letting you people know few very important, or usually you might find a question or you may not on this inverse trigonometric differentiation, because for JEE you will definitely need them, but I'm not sure if IIM Bangalore UG exam is going to test you on the differentiation of inverse trig, but they might, because it's not something very difficult to ask for. They can ask for it. So you should know the bare minimum. What is the differentiation of sine inverse x? is nothing but 1 by root over 1 minus x square. Should be knowing what is the differentiation of cos inverse x, which is nothing but minus 1 by root over 1 minus x square. You should be knowing tan inverse x, which is nothing but 1 by 1 plus x square. Similarly, I thought of dealing with exponential and positive number power. D by dx of e power x, when you see e power something, the differentiation is again e power x. Whereas if it is a power x, instead of e, a is some positive number here, a is some positive number greater than 0, then d by dx of a power x is nothing but a power x into ln a. See, in this, if you substitute a is equal to e, if a is equal to e, you will get d by dx of e power x is equal to e power x into ln e. What is the value of ln e? 1, right? E power x into 1. So basically, e power x differentiation is e power x, whereas a power x is a power x ln a. This is one thing. And the rest of the two which you should be knowing, or one to be precise, this is more important. That thing usually you find almost none questions. Almost none questions. But having said that, still they have a scope to frame a question. So you should be knowing that as well. Basically, log x differentiation, d by dx of log x or ln x is nothing but 1 by x. Is nothing but 1 by x. This is what I thought you people should be definitely knowing. I can prove why this sin inverse x d by dx is 1 by root over 1 minus x square, or cos is minus 1 by root over 1 minus x square tan. Basically, you will just take this sin inverse x as some theta. You will write d by dx of theta. Sin theta will become x. I can solve that one. Let's do one thing. Out of this 3, I will solve for sin inverse x. Then you go home and solve for cos inverse x and tan inverse x and prove that this is minus 1. Anyways, here it is written. But if someone is unable to see, this is plus 1 by root over 1 minus x square and this is minus 1 by root over 1 minus x square. So I'll just prove for sin inverse x. For the rest of the two, you can try it at your home. So if it is sin inverse x, we are doing d by dx of sin inverse x. Right? How to do this? Let this particular sin inverse x be is equal to some theta. Let this particular sin inverse x be theta. This is nothing but sin theta is equal to x. Sin theta is equal to x. Let sin inverse x is theta is nothing but sin theta is equal to x. Now, what is this d by dx of sin inverse x? We are doing nothing but d theta by dx, right? We wanted d theta by dx because I am assuming sin inverse x as theta. D by dx of sin inverse x is nothing but we are interested to find d theta by dx. Now I know sin theta is x. I assume sin theta to be x, or x sin inverse x as theta, that is nothing but sin theta to be x. So what is dx by d theta? If sin theta is x, what is dx by d theta? This is nothing but cos theta. This is nothing but what? Cos theta. This is nothing but cos theta, because if x is equal to sin theta, dx by d theta, that is differentiating sin theta with respect to theta, is nothing but cos theta. So dx by d theta is nothing but cos theta. But what is cos theta can be written as? Cos theta can be written as root over 1 minus sin square theta. Root over 1 minus sin square theta. Why is that? Because cos square theta plus sin square theta is equal to 1. I assume you people to know this trigonometry identity, cos square theta plus sin square theta equal to 1. Then this cos theta can be written as root over 1 minus sin square theta. So I did get dx by d theta is root over 1 minus sin square theta. That just I wanted reciprocal, that is d theta by dx is what I am interested on to. This has to be equal to 1 by root over 1 minus sin square theta. 1 by root over 1 minus sin square theta. This is what it is, because dx by d theta is root over 1 minus sin square theta. So just reciprocal, d theta by dx is 1 by root over 1 minus sin square theta. Now we are interested to find the same thing, right? D by dx of sin inverse x. That is what here we wrote here, d by dx of sin inverse x. So that is nothing but d theta by dx, that is d by dx of theta is what? Sin inverse x only, na? What we took was. So we are getting d by dx of sin inverse x is root over 1 minus sin square theta. But what is this sin square theta? What is sin theta? Sin theta is x. So this is 1 by root over 1 minus x square. 1 by root over 1 minus x square is d by dx of sine inverse x. Similarly, you could start solving for cos inverse, tan inverse. Even if you want, you could do it for secant inverse, cosecant inverse, cot inverse, any trigonometric. So basically, you should know the proof, how the things runs to do this, but always you need not keep doing this. It's better you remember at least these three, sine, cos and tan, because it reduces, it is smart to remember them to apply during exam. It is always difficult in order to keep deriving in this way. So this is one thing you have to take into picture, and then e power x, a power x and log x. Make a note of this. Now, this is an exemplar problem. Differentiate sine of ln x with respect to x. Sine of ln x with respect to x. That is nothing but we are given a function y is equal to sine of log x or ln x with respect to x. Here, what is now dy by dx? What is now dy by dx? As I mentioned, let's do one thing. Let's assume the same thing as chain rule. We will be doing the same chain rule. Let's assume log x is t. Then this dy by dx, or let's say y can be written as sin t. Y can be written as sin t. Dy by dx can be written as dy by dt into dt by dx into dt by dx. Y is equal to sine of log x. Let's assume log x equal to t. If y equal to sin t, then dy by dx can be written as dy by dt into dt by dx, chain rule. Now, what is dy by dt? Y is sin t. What is dy by dt? It is nothing but cos t. Into what is dt by dx? I know t is log x. T is log x. This implies dt by dx is nothing but 1 by x. As we have seen on the previous slide, log x differentiation is nothing but 1 by x. So dt by dx is 1 by x. I would write here now 1 by x. So I am getting dy by dx as cos t by x. But what is t? What is t? T is log x, right? Instead of writing t here, I'll just write log x. Cos of log x divided by x. Therefore, this is what dy by dx is. This is what dy by dx, cos of log x by x. So when you're doing it in exam, how you will do it? Directly you will say, okay, this is sine of log x. So the differentiation would be sine theta would be cos theta. So cos of log x, and I have to differentiate the term which is inside cos. So differentiation of log x is 1 by x. So y dash is nothing but cos of log x by x. Cos of log x by x. That's it. All right. Let us see further. Example, differentiate cos inverse of e power x with respect to x. Differentiate cos inverse of e power x with respect to x. How to do this? Now what we will do is basically, let's assume e power x as t. These all are examples. We will be finishing it, guys, within next let's say 10 minutes. The things will be done in 10 minutes. So let's assume e power x equal to t. Then y can be written as what? Cos inverse t. Cos inverse t. Because cos inverse e power x is given, I can write it as cos inverse t. Our goal is to find dy by dx, which is nothing but again dy by dt into dt by dx into dt by dx. Now when I say t is equal to e power x, this implies dt by dx is nothing but e power x only, because we have seen differentiation of e power x is e power x itself. So if t is equal to e power x, then dt by dx is e power x. What about dy by dt? If y is cos inverse t, what about dy by dt? We have seen on the slide, the formula is minus 1 by root over 1 minus x square. That is 1 minus t square, because cos inverse x differentiation is minus 1 by root over 1 minus x square. Here the function is cos inverse t. So minus 1 by root over 1 minus t square into dt by dx, as we have seen, it is e power x. Therefore, what we are getting is dy by dx turning out to be minus e power x divided by root over 1 minus t square. But what is t? T is nothing but cos inverse, t is nothing but e power x. T is nothing but e power x. So it is nothing but minus e power x by 1 minus e power x whole square. E power x whole square, that is nothing but minus e power x by root over 1 minus e power 2x. 1 minus e power 2x. So writing just t as e power x, we will be getting everything in terms of dy by dx is equal to minus e power x by minus root over 1 minus e power 2x. So while doing it in exam directly, how you will do this? Cos inverse x. So it is minus 1 by root over 1 minus x square. So this is what it is. But into, I should differentiate something which is inside cos. So that will be again e power x only. That is directly how you do it. Is everything clear? Cool. Just see the further slide. No. This is a question for you guys. Do this. I'll be giving 2 minutes. Time starts. After that, I'll explain. You can verify if you have got the right answer on your rough book. All right. Let me solve this now. Derivative of e power sine inverse x. So y is given e power sine inverse x. The lengthier process which we do for the sake of understanding is assuming sine inverse x to be some t. Let assume this. Then we write y is nothing but e power t. Dy by dx would be nothing but dy by dt into dt by dx. Chain rule. So now what we'll be doing, what is dy by dt? If y is e power t, dy by dt is nothing but again e power t. Differentiation of e power x is e power x. So dy by dt is e power t. What is dt by dx? If t is sine inverse x, this implies dt by dx is nothing but 1 by root over 1 minus x square. 1 by root over 1 minus x square. So if this is 1 by root over 1 minus x square, because sine inverse x differentiation is 1 by root over 1 minus x square, this into root over 1 minus x square. But what we know about this is e power t. You could see this, e power t is nothing but y, or e power t is nothing but y is nothing but e power sine inverse x. So this is nothing but e power t is y by root over 1 minus x square. This y is nothing but what? E power sine inverse x. So I can write this as e power sine inverse x divided by root over 1 minus x square. This will be the differentiation part of dy by dx. dy by dx for the given question. It is simply when I do it in the exam, I directly do it as e power sine inverse x is given. Usually e power x differentiation is the same e power x, but x I have to differentiate now. So this into what is the differentiation of sine inverse x? 1 by root over 1 minus x square. So directly it is e power sine inverse x by root over 1 minus x square. Now let us see. Now this is a good question indeed. Think about this. I will give 2 minutes. Think about this. This is the last topic which we discussed for today. Think about this, how to do this. Think of finding derivative of f of x is equal to x power sine x with respect to x. How to go ahead with this? Think of it. It may not be possible. It may be possible that you're unable to do it, or few people might do it well, but still think of it. We will discuss. All right. Let us see how to solve this question. Finding derivative of f of x is equal to x power sine x with respect to x. Now we were given function y is equal to x power sine x. We should be finding dy by dx. So usually the way of solving this is usually they tend to give a name known as logarithmic. One sec. They tend to give this a name of logarithmic differentiation. Logarithmic differentiation. What is this term meant to be? Logarithmic differentiation is that when you see something of this sort, first what we do is we apply logarithm on both the sides. Instead of assuming sin x as t or anything, we first do we directly do applying logarithm on both sides. So we get log of y is equal to log of x power sin x. X power sin x. But we know log of x power anything is nothing but I can get that onto this way, sin x to log x, because this is a logarithmic property. Logarithmic property is what? If I say log of 10 square, you say it is 2 because 2 into log 10 to the base 10, that is 1. So log x power sin x is sin x into log x. This is a logarithmic property. So we get log y is equal to sin x into log x. Now now this is the term of y in with respect to x. So what we do now is, now we differentiate with respect to x on both sides. Now we differentiate with respect to x on both sides. Log y differentiation is 1 by y. Log y differentiation is 1 by y. One sec, guys. What happened to this pen? All right. It's working, but then when I will write with other pen, no worries. So 1 by y, differentiation of log y with respect to x is 1 by y into dy by dx, because if it is log x, then the differentiation is 1 by x, but we are differentiating log y with respect to x. Now we are not differentiating with respect to y. We want what? With respect to x, right? We are differentiating both the sides with respect to x. So log y differentiation is 1 by y into dy by dx is equal to, now we are differentiating sin x into log x. Now we are differentiating sin x into log x. How to differentiate sin x into log x with respect to x? How to differentiate it with respect to x? We know uv, which is nothing but u into v dash plus v into u dash. This is what it is, uv rule or Leibniz rule or product rule. So first I'll differentiate, first I'll write sin x as it is and differentiate log x with respect to x. I will get this to be 1 by x, because sin x into log x differentiation is 1 by x, plus, now I will differentiate sin x, which should give me cos x, into log x will be written as it is. That is what it is, because first I will write first term as it is and differentiate second term, plus first term differentiation into second term. So sin x by x plus log x into cos x. So I am getting dy by dx can be written as, why I am taking it to the right hand side, y into sin x by x plus cos x into log x. Cos x into log x. So this is what dy by dx is. I can also write y in the terms of x totally, because y is nothing but the given function x power sin x. So I can, at the end, that is in the final way, I can write dy by dx differentiation is nothing but x power sin x into sin x by x, plus cos x into log x. This is what dy by dx is. What we have done is, they have given y is equal to x power sin x. First we applied log on both sides, then we get log y is equal to sin x into log x, then differentiate right hand and left hand with respect to x. You get 1 by y into dy by dx is equal to sin x into 1 by x plus cos x into log x. So dy by dx is y into this, y is nothing but x power sin x. This is what dy by dx turns out to be. So this way of first applying log is what this way of applying this log makes this way of approach known as logarithmic differentiation. This is used when basically this f of x, if you see here f of x, here f of x is given in the terms of what? Some function g of x power h of x, let's say g of x power h of x, because both are in the power and as well as the base, both are in the terms of x. In this case, g of x is x, sin x is h of x. So when the function f of x is given in the terms of g of x power h of x, that is some terms with in x power the term which is in x. So if this is the way it is given, if you see this kind of power anywhere when you are differentiating, immediately apply log on both sides, write it in this way. Once you write it in this way, then your works gets easier by simply differentiating both sides now with respect to x. So this is how we have to approach this. Anytime you see f of x equal to g of x power h of x, get the notion of applying logarithmic differentiation into your brain. Then when you see this, immediately you do logarithmic differentiation. So this is one way of questions which you can see in the exam. As we are up with the time for today, let us stop over this place. We covered a lot in the last two, in the yesterday's and today's session: limits, derivatives, continuity, differentiability, different kinds of derivatives, inverse trigonometric derivatives, e power x, implicit, logarithmic differentiation at the end. We have also seen discontinuous functions, graphs, greatest integer functions, limits, how to solve different limits using the sandwich theorem, where we have talked about why f of x, g of x, h of x is having an lesser than inequality, then how the limits coincide. If extreme limits coincide, then obviously that function which is in between those both should also coincide with the limit. So we used all of them. Mostly we have covered the core basics of differential calculus. I would say differential calculus, it's not integral still. Differential calculus, most of the part is done, the major part is done. Still probably we are left with only few topics, let's say like second derivative, which is f double dash x. Till now we discussed f dash x, how to do f double dash x, which is d square y by dx square. Or we are left with polar coordinates. Polar coordinates is very rare. I'm not expecting a question from it, but we can cover basic things about it. And these two topics are left behind. And application of derivatives, basically, if you are good in solving this algebraical way, this is what mostly exam tests you. But application of derivatives is one more chapter where you will see usually the circle radius is increasing, or some deformation in the objects. So at what rate they are changing. Basically, the rate is nothing but dy by dx. So how to deal with those kind of problem statements? Instead of giving algebraic equation, they give a problem statement. We should be able to interpret it in the terms of algebraic and solve for the answer. So these three things: polar coordinates, double derivative, that is second derivative, f double dash x, and the third one is application of derivatives. If we finish that, I guess we will be done with the differential calculus part. Thanks for tuning in, guys. I hope you keep practicing. Then you will be doing good in your exams. All the very best. Thanks for tuning in.